everyone! Today we're going to be starting locus and parabola. More specifically, we're going to be focusing on locus. Now, locus is a set of points that describe some characteristics, okay, the same characteristic. So, usually a locus is described by an equation, okay, that describes the set of points, okay. So, today's lesson we're going to be focusing on how to derive some equations, okay, by using specific methods to find the locus of a set of points. Okay, so starting with a locus and its equation. Okay, now a locus is a set of collection of points which have same relations. Okay, so again, as I said previously, it's a set of points that share the same characteristics or same relations. Okay, now the example shows a locus of points which its distance from the y-axis is equal to its distance from the x-axis. Okay, so this is an example. Okay, these points describe the locus because, have a look, all of these points have the same distance. This point has the same distance from its y-axis as its x-axis. Okay, so this distance is equal to this distance. Okay, this distance as well, this point as well, its distance from the y-axis is same as the distance from its x-axis, and then that applies for all of these points. Okay, so basically this is an example. So this locus will probably be described by a straight line. Okay, that's what locus is. Okay, so we can derive its equation by looking at what its points look like. Yeah, so we'll try to do that. Now, question 1. A point P, well, we don't know what P is. P is any random point that can move around the axes. So I'm just going to put P as P, point P as P with coordinates x, y, okay? And P moves so that its distance from the y-axis is always equal to its distance from the x-axis. So this is similar to our example just prior to this one, isn't it? So find the equation of the locus of P. Okay, basically, so the point P has the same distance from its y-axis as from its x-axis, isn't it? So if I draw a diagram, it's going to look something like this. This is P, okay? This is P, and its distance from A is same as its distance from B. Now the coordinates of B is going to be 0, y. I know that the x-coordinate is going to be 0 since it's going to be any point on the y-axis. Any point on the y-axis, x is 0. Okay, and we don't know what y is, so I'm just going to call y. But this y is same as this y, isn't it? Since they're horizontally on the same line. Okay, now A is going to be x, 0. I don't know what x is because this point can vary, but it will always be the same x value as this one because they're vertically on the same line, same vertical line, right? So this x-axis, this x-coordinate will be the same as this x-coordinate. Okay, now on the x-axis, y is always 0, so that's why I put 0 there. Okay, now P is xy, so I can say that PA equals to PB because this distance equals to this distance all the time. No, okay, that's how P moves. P must move so that PA is always equal to PB. Alright, now this is talking about distance, so I'm going to use my distance formula to first find PA. It's going to be root x2 minus x1 squared plus y2 minus y1 squared. x2, I'll call it like this, I'll go x minus x squared plus y minus 0 squared. Okay, and then simplify. Look, x minus x is 0, so 0 squared is just 0. Now y minus 0 is y, so it's going to be root just y squared. Okay, and that's going to be simplified to absolute value of y. And guys, you must put absolute value. You must have absolute values because I know square root and square cancels each other. But look, the distance must be positive, okay? The distance must be positive. You cannot have a negative distance. So therefore, it's going to be absolute value of y. And this is a very important thing. You must include your absolute value bars. Okay? So think about what we're talking about, okay? We're talking about distance. Distance must be positive, so we have absolute values around it. Okay, so we've got PA. Let's do PB. PB is square root of x minus 0 because we've got x minus 0 squared plus y minus y squared. Okay, so we're doing the same distance formula. So I hope you remember what the distance formula is. So I've got that. Look, y minus y is 0. 0 squared is 0. And look, x minus 0 is x. So we're simply left with x squared, square root of x squared. And similarly, this is just going to be absolute value of x, okay? Because look, this is also distance, so we must put absolute bars around it, because distance must be positive, okay? So what's our rule, guys? Our rule is that PA equals to PB, so therefore I'm going to let PA be equal to PB, just like this, okay? If we have absolute bars around both, we can say that y equals to plus or minus y. If we put a positive x in there, it's going to be positive, and even if we put a negative in there, it's still going to be positive. Everything will be positive, so it doesn't matter if we put plus or minus. Okay, so in this case, y is going to be plus or minus x. All right, that's the answer, guys. And if you want me to draw a diagram, it's going to look something like this. So y equals to positive x is this yellow line here, and y equals to negative x is this one over here. Any point on either lines, say if I that point there, the distance to the x-axis is always going to be the distance to the y-axis, okay? So no matter what point on these two lines, the distance to y is always going to be the same as distance to x-axis, okay? So if you like a little graphical demonstration, that's what it's going to look like. Okay, so I hope that makes sense. I hope that was a bit simple. But guys, remember, absolute bars is always, you need to put the absolute bars, especially when we're talking about distance. Okay, so that's question 1. Have a look, guys. Okay, and first you must always build up a property or a characteristic that make this locus applicable. Okay, so in this one, PA must be equal to PB. Okay, so that's question 1. Let's move on. Okay, question 2 says a point P, again it's going to be xy, moves so that its distance from the y-axis is always double to its distance from the x-axis. Okay, so find the equation of the locus of P. So again, guys, this time it's a bit different to question 1 because it says the distance from the y-axis is going to be double the distance from the x-axis. So basically, if this is P, again A is going to be represented as x0 since it's on the x-axis, and this is going to be B, okay, 0y since it's on the y-axis. Okay, so it says the distance from the y-axis, this distance, is going to be twice the distance of the distance from the x-axis. So 2 times PA is going to be PB. So that's why I wrote 2PA is PB. Okay, so that's our condition for this locus here. Alright, so now I'm going to find PA. PA is going to be absolute value of y because, look, the y coordinate of this point is y. So therefore this distance is y. So therefore this distance is y, and we represent distance as absolute value of y since distance must be positive. Now, PB is going to be absolute value of x since this distance here is going to be x, right? Because the x coordinate of this point is x. So therefore this distance is x, and we represent distance as absolute value of x, right? So therefore I'm simply going to apply my condition here just like this. So 2 times PA, PA is that, so I'm going to say 2 absolute value of y equals 2 PB, which is that, so absolute value of x. And then here, guys, you can say that absolute value of y is going to be half absolute value of x. Just divide both sides by 2 since I want to solve for y. Therefore y is going to be plus or minus 0.5x, 0.5 or half. Okay, and remember the plus or minus, okay? Plus 0.5x is equal to negative 0.5x because we're going to put it inside the absolute bars anyway. It's going to turn out positive, so both answers are applicable. Okay, so that's the answer, guys. Plus or minus 0.5x. If I draw a diagram, that's what it's going to look like. This is positive 0.5x. This is negative 0.5x, okay? So any point on those two lines is going to make this condition true, all right? So that's the locus. That's the locus of question 2. So have a look, guys. And let's move on. So question 3 says, write down the equation of the locus of a point P, okay, that the distance from the x-axis is square of the distance from the y-axis. So this time, it's going to be like this. Again, it's going to be very similar to question 2 and 1, the diagram, because this is going to be A, x0. This is going to be B, 0y, since they're on the x and y axes. And now, because it says the distance from the x-axis, this distance is square of the distance from the y-axis. It's going to be square of this one. So I'm going to say PA is PB squared. Okay, so that's the condition for this question. Alright, so guys, hopefully you can say that PA is going to be absolute value of y again, since that's y, so this must be y, so it's absolute value of y for distance. And PB is going to be absolute value of x, since this is x, so that's x, so distance is going to be absolute value of x. So I've got PA and PB, so we can put it into this condition here, so that PA is absolute value of y, so absolute value of y equals to PB squared. So absolute value of x squared. Okay, and guys, basically, absolute value of y is going to be just x squared. X squared and absolute value of x squared is the same thing, because anything squared is going to be positive as well, right? So we don't have to put the absolute bars there. And then therefore, y is going to be plus or minus x squared. Okay, it can be negative x squared, because if we put a negative value inside, it's going to turn out positive anyway. So remember that we must put plus or minus. Okay guys, so that's the locus of question 3. That's the answer for question 3, guys. That's the locus. And guys, whenever you see absolute bars, you must consider your plus or minus. Okay, usually we need the plus or minus sign. So guys, that's the locus. All I did was apply this condition, okay, and then found my equation. Therefore, if I draw a diagram, it's going to be these two. It's going to be positive parabola or a negative parabola. Okay, that's positive x squared, negative x squared. So anything on that line will make this condition true. Okay, so that's question 3. Hope that makes sense. And let's move on. Okay, so question 4 says, find the equation of the locus of a point P that the distance from the x-axis equals to the distance from x equals to -1. Okay, so this time they give us a line, okay, basically looks like this. This is x equals to -1. I just put it in dotted lines. Okay, that's x equals to -1. This is P. Okay, P can be anywhere, but I just put it there. And A is again x0, since it's on the x-axis. And B is going to be on the x line x equals to -1. So the coordinates of B will be -1, y. Now it's going to be y. Y can be anything, because it can move around this line. So y is just going to be y. This y is going to be same as this y, because they're horizontally on the same line, aren't they? That's y. But the x coordinate is -1, since anything on this line, x is going to be -1. So the x coordinate will be -1. Now, the rule is that PA, this distance, must be equal to PB, which is this distance. That's what the question says, okay? This distance must be equal to this distance. So guys, PA, I'm going to use the distance formula this time. So square root of x minus x squared plus y minus 0 squared. Okay? Now I hope you can see that x minus x is 0, so 0 squared is 0. X minus 0 is, y minus 0 is y, so we have y squared. So it's absolute square root of y squared. And that's just going to be absolute value of y. Don't just say y, it's absolute value of y, since it refers to distance. It must be positive, right? Now PB, again I'm going to use my distance formula. Square root of x minus 1 squared, so x plus 1 squared, plus y minus y squared. Okay? And then this is going to be 0, right? Y minus y is 0. And then it's going to be left with just square root of x plus 1 squared. Okay? And what is this going to be, guys? Basically, this will be x plus 1 absoluted. Okay? I know that this and this will cancel each other. But again, this distance must be positive. So therefore, this must be absolute value of x plus 1. Okay? So please don't forget your absolute values. Now, we've got PA, we've got PB. So I'm going to apply my condition that PA equals to PB. This is PA, this is PB. So absolute value of y equals to absolute value of x plus 1. Okay, so therefore guys, y equals to positive x plus 1 and negative x plus 1. Negative x plus 1, if I expand that out, it will be negative x minus 1. Okay, so again, we have two different equations for locus. Yeah, so guys, you can see that if I draw a diagram, this one, y equals to positive x plus 1, is going to be represented by this line here, and y equals to negative x plus 1, or basically negative x minus 1, is going to be that line there. So any point on that line, okay, will make PA equal to PB, or the distance from the x-axis equal to the distance from that line there. And guys, when we're talking about distance from a point to the line, we always refer to the perpendicular distance, okay? So please remember that it's not just any old distance, any distance that we can find. It's always the perpendicular distance that we're going to refer to, okay, if it's a point to a line. Alright, so that's something you must remember. But anyway, that's the answer. Those two represent the locus of point P. Okay, so that's question 4. Have a look. And we'll move on. So question 5 says write down the equation of the locus of a point P that the distance from y equals to 2 equals the distance from x equals to negative 1. Okay, so this time they give me two different equation of a line, y equals to 2 and x equals to negative 1. So the distance to that line is equal to the distance from this line. Okay, so that's my diagram. I know it maybe look a bit confusing, but basically this is x equals to negative 1, this line here, and this line here is y equals to 2, that line there. Okay, and this is P, it can be any point. Now the distance of P to y equals 2, remember it's always going to be the perpendicular distance, okay? When it says distance to a line from a point, it must always be the perpendicular distance. So it's going to be this point to this line, this point here, that distance, A, if that point is on the y equals to 1, I'll just call it A. Okay, now y is going to be definitely 2 because it's on line y equals to 2. So on this line, the y coordinate will always be 2. That's 2. And this x will be the same x coordinate as this x, since it's vertically on the same line. So that's x. The coordinates of A is going to be x2, no matter where that point is. Okay? And this point, of course, as similarly to question 4, is going to be B, which is going to be negative 1y. This is going to be y because the point, it can vary. It can be anywhere on this line. So I'm going to call it y because it's same as this y, horizontally on the same line. So this y must be equal to this y, right? And because this line is x equals to negative 1, the x coordinate must be negative 1. Okay? So it says that this distance is equal to this distance, and again this distance must be the perpendicular line, okay? So we can say that PA equals to PB, this distance is equal to this distance. Therefore, I'm going to use my distance formula to start off by finding PA. PA is going to be x minus x squared plus y minus 2 squared. Okay, hopefully you can see that this is 0 because x minus x is 0. So we're left with square root of y minus 2 squared, which is absolute value of y minus 2. Don't just say y minus 2, it has to be absolute value of y minus 2 since it refers to distance. Okay, now PB is going to be x minus 1 squared, so x plus 1 squared plus y minus y squared. Okay, and again, hope you can see that this is going to be 0, okay, since y minus y is 0. So we're left with absolute value of x plus 1 squared. Okay, and that's going to, square root of x plus 1 squared. I'm mixed up with the absolute bars. So that's going to be absolute value of y plus 1. Okay, and remember it must be absolute because it's distance that we're talking about. Okay, so we've got PA, we've got PB. So now we're going to apply our condition that PA equals to PB like this. PA is absolute value of y minus 2 and PB is absolute value of y plus 1. So therefore, y equals to x plus 3 and negative x plus 1. Basically, look, y minus 2 can be positive x plus 1 and negative x plus 1, right? And this is simplified to negative x minus 1, isn't it? This one here. So if I move 2 over, it's going to be x plus 1 plus 2, which is going to be x plus 3. And this one over here, negative x minus 1 plus 2 will be negative x plus 1. So therefore, that's why we come up with these two equations. That's the equation of the locus for question 5, okay? The equation of the locus of point P. Alright, so if I draw a diagram again, this represents y equals to x plus 3, and this line represents y equals to negative x plus 1. So any point on that line will make the distance from y equals to 2 equal to the distance from to y equals to negative 1. Okay, and remember, distance from a point to a line is always the perpendicular distance. Okay, so I hope you remember that. So that's it. That's question 5. So we have, again, 2 different locuses, equation of the locus. Those are the answers. Alright, so have a look at that, guys. And that's it. So that was basically locus, guys. With these locus questions, always look at the condition or the characteristics they provide to you. Okay, and then use it. Alright, and make sure with distance, always apply your absolute bars. That's a very, very important thing as well. Okay, otherwise you won't end up with the 2 answers that we need. Okay, so just be careful. That was question 5.